Hello, welcome to the video. In this lesson, we're going to be looking at section 8.1, where we're going to look at similar figures. Now, up to this point, we have looked at congruent figures, which means is you had two figures that were exactly the same, which meant that their corresponding angles were congruent and the corresponding sides were also congruent. There were some things like when we dealt with triangles, how we could prove that, and there are correlations between finding if figures are congruent and when figures are similar. So when something is similar, we are going to look at two similar concepts to congruent figures. When two figures are similar, we're still going to look at the corresponding angles and the corresponding sides. So just like congruent figures, our corresponding angles must be congruent. So whether they're similar or whether they're congruent, the angles have to be congruent, okay, with respect to the two figures in question. Where it differs is when you're looking at the corresponding sides. The corresponding sides are not going to be the same measurement. But what we have to take a look at is each individual corresponding side must be proportional to the respected sides of the figure. And if you can say that all sides are proportional, all corresponding angles are congruent, we can then make a conclusion that those two figures are similar. Here is an example. So I'm going to circle this. This is an example of what is called a similarity statement. So they're saying here that triangle ABC is similar. This symbol right here, like this like wavy line kind of symbol is the symbol for similar. So I'm just going to also circle that and say this is similar. That this similarity statement says that triangle ABC is similar to triangle DEF. So that means that all corresponding sides, so like angle A and angle D are congruent, B and E are congruent, C and F are congruent. And then you can say that the corresponding sides are congruent as well. In this example problem, it says in the diagram, triangle RST is similar to triangle XYZ. So since they gave us this particular statement, they're telling us that it's similar. So since it is similar in the problem, it possesses all of the characteristics of similar figures, which means that corresponding angles are congruent and corresponding sides are going to be proportional. So the first question that gets asked is they want us to find the scale factor between triangle RST to triangle XYZ. All right, so the first thing you have to realize is how they order this makes a difference in how you determine the scale factor. Since our first triangle, RST, is larger, or it appears to be larger through the measurements and just looking at it, we can say that when it comes to scale factor, how is it, so going from this shape to this shape, does it get bigger or does it get smaller? And in this case, it gets smaller. So since it gets smaller, that means that our scale factor is going to be a value that falls between 0 and 1. So our answer is going to fall between 0 and 1. So it's going to be a fraction of some kind. So what you're going to do is I am just going to choose two corresponding sides. You can choose any two corresponding sides that you like, and they're going to help us determine what the scale factor is. So I look at this one right here, xy, which is my first and second term in the similarity statement, and then I look at the first and second term of this side, which is rs. So 20 and 12 are going to be proportional sides. They're corresponding sides. So since I know that my scale factor must be between 0 and 1, my fraction has to be written as 12 over 20. And then this gets reduced to 3/5. So my scale factor for these two similar figures is 3/5. Now for B, it just says make a list of all congruent angles. So I look at, first off, angle R. That is going to be congruent with angle X because it's the first letter in the statement, first letter in the statement in both triangles. Next, it's going to be angle S is going to be congruent to angle Y. And then finally, to finish up, angle T is going to be congruent to angle Z. So it's just in the order. The last thing it says, write the ratios of the corresponding side lengths in the statement in a statement proportionality. So you are just simply going to write it as follows. So you're going to take, so since it was 3/5, so we're taking all of the side measurements of the smaller triangle for part C, and we're going to write it out. So we already did xy. So let's just say we write xy, which was the 12, divided by the rs, which was the 20. So that's my first one. That is going to be equal to, so now if I looked at st, so let's just say I go st, which would be down here, divided by yz, because that's second and third. And then finally, to finish this up, it would be RT, that's going to be written on the bottom, divided by XZ. And that is the proportionality statement that they're looking for. I was able to take all three of the side measurements and match them up with the corresponding sides with respect to the similarity statement. Here it talks about, it says corresponding lengths in similar polygons. So it says if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygon. So once you realize that two polygons are similar, you can simply use the scale factor to help you find other values of any unknown side measurements. So for this example here, they're asking you to find the value of x. So using that statement, what you can then say is you could rewrite this as a proportion. They're telling you that these two triangles are similar because of the similarity statement. So what we're going to do is I'm going to look at two measurements that I do know. So like DF and MP. So I know that one is 20 and the other one is 24. They're corresponding sides, so I can write that as a proportion. It's going to be equal to, my unknown value is EF, that's second and third. So second and third is MP, NP, so that's 30. So I write this as a proportion to solve it using cross product. So 24 times x is 24x. It's going to be equal to 20 times 30, which is 600 divided by 24. X is 25. So again, using that same idea, what they have here now is they want you to find the altitude of line segment PS. So they want you to find the distance from here to here. So that is like trying to find X. Well, they give you the altitude of PY. They're telling you that these two triangles just so happen to be similar. So what you can do is say, all right, TR is 12 over XZ, which is 16. That is going to be equal to, so since I wrote the 12 on the top, and that is in correlation with triangle TPR, the unknown is X, so I have to write X on top, staying consistent with my similarity statements, and then it's going to be divided by 20, which is the altitude that we do know from the other triangle. So I do the cross products here. I get 16x is equal to 20 times 12, which is 240. Divide everything by 16. X is 15. So the altitude for PS is 15. All right, so now here, again, we have another similarity statement. They want us to find X. So we have quadrilateral, and they're telling us that the two quadrilaterals are similar. So here, I'm trying to find BC. BC is the second and third letter in the statement. So RS is going to coincide with that. So that's my correspondence. So I can write this as X over 4. So to find that unknown, all I got to do is find something that I do know. So let's say if I went like CD, which was 16, that goes on top because that's part of the value of X. And then ST, which is 8, so which would go here. Do the cross products. I get 8x is equal to 16 times 4, which is 64. Divide that by 8x equals 8. Over here, they're telling us that the two triangles are in fact similar. What we don't know is they want us to find Km. So Km is right here. Well, luckily they give us this angle here, which is 35. So this is like X. So I'm going to say like X over 35 is going to be equal to, and then since this is what 48, so I put the 48 on top because that coincides with my variable X, and then I would write in 40. So here doing the cross products, I would get 40x is equal to 48 times it by 35, which is 1680, divided by 40. X is 42, or Km is 42 in this example. Here, they're saying that we have a talk about perimeters of similar figures. Here it says if two figures are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. So you could say that all you would have to do is add up all of the side measurements for one, divided by the perimeter of another, and then you would get the ratio of your perimeters between the two similar figures. So here it states that a town plans to build a new swimming pool. An Olympic pool is rectangular with lengths of 50 meters and a width of 25 meters. The new pool will be similar in shape to an Olympic pool, but will have the length of 40 meters, and they want you to find the perimeters of an Olympic pool and the new pool. So a couple things you can do. Well, first, they give us the Olympic pool in the diagram. So to find the perimeter, it's a rectangle, so I can say this is 2L, which is 50, plus 2W, which is 25. That's 100 plus 50 is 150 meters. So the perimeter is 150 meters for the Olympic pool. All right. Now, what we can now say is with the other pool with respect to scale factor. So we could say like, oh, so this is the new pool. So this has got 40 meters in length. That's all we know. But we can use that to create a scale factor. So between this shape and this shape, it's getting smaller. So I know that my scale factor is going to be a fraction. That's between 0 and 1. So I can just take my known value here, which is 40, divided by my known value here, which is 50, and that means my scale factor is 4/5. So how is that helpful? Well, what we can do now is say, okay, we know that the perimeter of our Olympic pool is 150 meters. We know that it is a scale factor of 4/5, and to figure out the perimeter of the new pool, we can put that and make it an attachment for x. So then when I do the cross products, we can get the perimeter for the new pool, or at least the pool that is similar being built. So this is going to be 5x is equal to, 150 times it by 4, which is 600, divided by 5, which is 120 meters. So our pool, or the pool that is getting put together, has a perimeter of 120 meters. All right, so here it says these two gazebos shown are similar pentagons. They want us to find the perimeter. So what you can do first is let's find the perimeter of gazebo B. So looking at gazebo B, we can say that, well, it's 15 plus 9 plus 12 plus 15 plus 18, which gets us, so gazebo's B is 69 meters. Okay, so between the two, this one, between gazebo A and gazebo B, it's gotten larger, so I know that my scale factor is going to be a ratio that is larger than 1. So we can say, like, it looks like 15 over 10. So I just use these two measurements here. And 15 over 10 reduces us to 3/2. So to figure out the perimeter of gazebo A, I can say, well, I have 3/2 here. I know that gazebo A is 69 degrees. I know it's the larger of the two, and then I can just put x on the bottom because I know that's a smaller number. The reason why I know it's a smaller number is because 3 is smaller than 2. So 3 times x is 3x. 2 times 69 is 138. Divide that by 3. I get x equals 46, and it's meters. So the perimeter for gazebo A is 46 meters. The final thing that we're looking at is talking about similar figures with respect to their perimeters, or not perimeters, their areas now. Now they're saying that if two polygons are similar, then the ratios of their areas is equal to the squares of the ratios of their corresponding angles. So what now you have to do is square those ratios. So looking here, it says that triangle ABC is similar to triangle DEF. They want us to find the area of DEF. So they tell us the area of ABC, which is 36 square centimeters. Well, the first thing we can do now is look at our two figures. Looking from figure 1 to figure 2, it is going to be smaller. So I know that my scale factor is going to be something that is um, smaller than the original. So what we can now say is, in order to get your scale factor, what it's going to be, it is going to be what, 5/10, which is what, 1/2. So that's my scale factor. So how is that useful with respect to area? So now to find area, you got 36, which goes on the bottom, and then you got this 1/2. But what you have to do with your 1/2 is you must square it with respect to x. So now what I get is x over 36 is going to be equal to what, 1/4. So now when I do the cross products, I get 4x is equal to 36. Divide everything by 4, x is equal to 9. So 9 square centimeters is going to be my area to triangle DEF. And that is being able to look at similar polygons. Hope this helps. Till next time.